All right, let's add some fractions that have different denominators. So we're trying to add 1/2 and 1/8 here. So if I use fraction tiles to model this, if this is 1 whole, 1/2 looks like this, the 1 whole split into 2 pieces. There's one of them. And then the 1/8 looks like this, 1 whole split into 8 pieces, and we have one of them. So we're trying to add 1/2 and 1/8. So if I put them together, add them, well, here is my sum, but how do I know how to write this? Because we've got halves and eighths. We've got different size pieces. So, I can't do this. I can't add halves and eighths because they're different size pieces. What I need to do is I need to add the same size pieces. So can I make halves into eighths? Well, let's see. Adding some eighths tiles here. 3/8 is not enough. 4/8. Oh, look at this. 4/8 fits perfectly into 1/2. So 1/2 can be rewritten as 4/8. And then we just add the other 1/8. And so 4/8 plus 1/8 is 5/8. 1, 2, 3, 4, 5. 1/8, 5/8. So 1/2 plus 1/8 is 5/8. But we had to get the same denominator, the same size piece, before we could add them together. So the next question you might be asking is, yeah, that's great if I have fraction tiles, but what if I don't have fraction tiles? How do I figure out how else I can rename 1/2? What other denominators will work to make a fraction equivalent to 1/2? Well, I'm glad you asked. Let me go to a clean piece of paper. And so if we're trying to figure out which fractions are equivalent to 1/2, let's try out a bunch of denominators. We'll try out thirds, we'll try out fourths, fifths, sixths. Unfortunately, I don't have sevenths tiles. We can try out eighths. All right, so let's try a few of these. How many thirds will equal 1/2? I do have some thirds tiles. There's 1/3, that's a little smaller than a half, and 2/3, 2/3 is larger than a half, so there are no amount of thirds that will equal 1/2, so that's not going to work. Okay, what about fourths? 1/4 is smaller than 1/2, and 2/4. Oh, hey, 2/4 equals 1/2. It's the same. So 1/2 does equal 2/4. Let's try fifths. 1/5 is smaller than a half. 2/5 is smaller than 1/2, and 3/5 is larger than 1/2. So the fifths tiles don't work. All right, let's try sixths. 1/6 is smaller than a half. 2/6 is still smaller. 3/6. Ooh, this can be close. Yes, they're a perfect match. 3/6 is the same as 1/2. Awesome. I wish I had sevenths tiles, but I don't. So we're going to have to move on to eighths tiles. And you just saw that 4/8 equals 1/2. I'll put them up here again. 4/8. Okay, so sevenths won't work. I don't have tiles to show you. But what do you see here? The denominator of 2, 2, 4, 6, 8. Hey, I'm counting by 2's here with the denominators that will work. All the multiples of 2, 2, 4, 6, and 8, all these you can make equivalent fractions with 1/2. And that works for every fraction. Whichever fraction you're starting with, if you just count the multiples of that denominator, you can make an equivalent fraction with that denominator. So how would I know how many fourths equal a half? Well, fourths are 2 times as small as halves, so you need twice as many of them to make an equivalent fraction. Sixths are 3 times as small as halves, so you need 3 times as many of them to make an equivalent fraction. And eighths are 4 times as small as halves, so you need 4 times as many of them to make an equivalent fraction. Okay, so now let's try a problem like this with 2 different denominators once again, and let's do it without fraction tiles. So I'm trying to add 1/2 to 2/5. So I know I said without fraction tiles, but I just want to prove to you that 1/2 and 2/5, these are different size pieces, so we can't add them. We need to get them in the same denominator. So we just learned that you can get equivalent fractions by finding the multiples of each denominator. So the denominators here are 2 and 5. So I'm going to start with 2. So 1/2 could be made into fourths, sixths, eighths, or tenths. Those are all the multiples of the denominator 2. So let's look at the denominator 5. 5 can be made into tenths, 15ths, 20ths, 25ths, and so on. Now, if I want to look at my 2 lists, I see that, hey, I can make halves into tenths, and I can also make fifths into tenths. They have that common multiple. So if I make both these fractions into tenths, I'll be able to add them. So now, how do I do that? How do I figure out how many tenths 1/2 equals? Well, how many times smaller are tenths than halves? It's the 1, 2, 3, 4, 5th multiple of 2. Tenths are 5 times smaller than halves, so we need to take 5 times as many pieces to make the same amount. So 1/2 is equivalent to 5 tenths. So now let's do the same thing to 2/5. How many tenths are 2/5 equal to? Well, 10 is 2 times 5, so tenths are twice as small as fifths, so we need to take 2 times as many pieces to have an equivalent amount. 2/5 is the same as 4 tenths. So now we can rewrite this equation. Instead of 1/2, we're going to write 5 tenths. Instead of 2/5, we're going to write 4 tenths. And then when we add them together, 9 tenths is our sum. So this is how to find common multiples, so you get a common denominator, so you can add these fractions that have different denominators. Now let's check this with fraction tiles just to make sure that we've done this correctly. 1/2 plus 2/5. So 1/2 looks like this, and we said that 1/2 is the same as 5 tenths. So let me grab my tenths. 1, 2, 3, 4, and 5. 1/2, in fact, does equal 5 tenths, like we said, because the tenths are 5 times as small as halves. Now the 2/5 we said equaled 4 tenths. So let me put my 2/5 up here. Make sure that that equals 4 tenths. 1, 2, 3, 4. Yes, those are equivalent because tenths are twice as small as fifths. So we've proven that 1/2 plus 2/5 does equal 9 tenths. There are 9 1/10ths altogether here.